Typhoon Dolphin formed on the 27th of July at 176.9 degrees east longitude, essentially on top of the international dateline. Typhoons are not supposed to form there. 13 days and more than 6,000 kilometers later, it came ashore in eastern China, and China's own forecasters called it something that has never happened since meteorological records began. More than 1 million people were evacuated ahead of it. By the end of this, you'll understand exactly what changed in the Pacific to make that possible, and why it is still changing. At about 5:30 in the afternoon local time yesterday, Typhoon Dolphin came ashore near YUHUAN, on the eastern coast of ZheJIANG Province, China. Maximum sustained winds near the center measured 42 meters per second, 151 kilometers per hour, which puts it at Category 1, equivalent on the Saffir-Simpson scale. A little over an hour later, at roughly 6:40 in the evening, it made a second landfall on the coast of Wenzhou, farther down the same shoreline. It is the most powerful tropical cyclone to strike China this year. Taken purely as a landfall, that is not a remarkable event. China absorbs storms in this class routinely. Its coastal provinces have some of the most rehearsed typhoon response machinery on the planet, and a Category 1 equivalent arriving on a prepared coastline is, in the grim arithmetic of disaster management, a manageable problem. If that were the whole story, it would be a wire item and nothing more. But that is not why China issued a red alert yesterday morning, the highest level in its national typhoon warning system. And it is not why more than 1 million people were moved out of the way before the storm arrived. The reason this storm got that treatment has almost nothing to do with how hard it hit. It has to do with where it came from. Typhoon Dolphin formed on the 27th of July at roughly 13.2 degrees north latitude and 176.9 degrees east longitude. If you put that on a map, it sits essentially on top of the international dateline at the far eastern edge of the Northwest Pacific Basin, about as far from the Chinese coast as it is possible to be and still be in the same ocean. Typhoons do not form there. That is not a figure of speech. Observational studies of the basin establish that under La Niña conditions, more than 90% of Northwest Pacific tropical cyclones originate west of 160 degrees east. During El Niño, the genesis zone stretches eastward to roughly 170 degrees east. Dolphin formed at 176.9 degrees east, beyond even the El Niño shifted boundary, out past the edge of the map where these things are supposed to begin. China's National Meteorological Center has stated the consequence plainly. Dolphin is the first typhoon on record to form near the international dateline and go on to strike China at tropical storm intensity or above. Dong Lin, a chief forecaster at that agency, described the formation point as something that has never happened since meteorological records began, and called Dolphin an exceptionally rare system. Independent analysis, published by Yale Climate Connections, goes further and calls it the strongest typhoon on record to develop that close to the dateline. That is the fact underneath the red alert. The warning was not calibrated to the wind speed at the coast. It was calibrated to the recognition that nothing in the record looks like this. Here is the part that turns an oddity into a genuine problem. A storm born that far east has thousands of extra kilometers of open ocean to cross before it reaches anything. Under normal circumstances, that distance is a death sentence. It is a longer window for wind shear to tear the storm's structure apart, a longer window for dry air to work its way into the core, a longer window for the storm to recurve north into colder water and unwind harmlessly at sea. The overwhelming majority of systems that form that far out never reach a coastline in any meaningful state. Dolphin did the opposite. Within roughly 24 to 36 hours of genesis, it went from Category 1 equivalent to Category 5 equivalent in an explosive intensification cycle that analysts clocked at under 36 hours from start to finish. On the 30th of July, it peaked with maximum sustained winds of 165 miles per hour, 270 kilometers per hour, and a minimum central pressure of 910 hectopascals, positioned about 181 nautical miles southwest of Wake Island. NASA's Earth Observing System clocked 140 knots at 600 hours, coordinated universal time that day. Chinese reporting recorded the peak as 65 meters per second, which places it at 417 or above and makes it the second most intense typhoon of the year. That made Dolphin the fifth Category 5 tropical cyclone on Earth in 2026. All 5 of them occurred in the Pacific. That puts this year ahead of the pace of 1997, the all-time record year for Category 5 storms globally, which finished with 12. Then it kept going. It completed at least one full eye-wall replacement cycle, the process where a storm's inner ring of thunderstorms collapses and a larger outer ring takes over. That normally costs a storm peak wind speed, even as it widens the damage footprint. Analysts tracking Dolphin noted it appeared to attempt a third intensification peak afterward. China's own forecasters listed frequent fluctuations in intensity as one of the storm's defining characteristics, alongside its distant open water formation, its long lifespan, and the sheer size of its circulation. That behavior is worth pausing on, because it is a forecasting problem as much as a meteorological one. A storm that follows a single clean intensification curve is something forecasters can extrapolate. A storm that repeatedly weakens and then rebuilds across a 2-week lifespan resets the confidence interval on landfall intensity every time it does it. Every agency issuing guidance on Dolphin was doing so against a system that had already changed its mind several times, and that uncertainty is one of the reasons the preparation footprint in China ended up as large as it did. When you cannot narrow the range, you prepare for the top of it. It passed near Wake Island. It tracked west-northwest along the southern flank of the subtropical ridge. On the 6th and 7th of August, it swept through Japan's southern Okinawa prefecture with sustained winds of 162 kilometers per hour and gusts to 216, injuring 6 people, knocking out power to nearly 39,000 buildings in Kagoshima and more than 12,000 in Okinawa, and grounding flights on both All Nippon Airways and Japan Airlines. And then it kept going west. By the time it reached Zhejiang, Dolphin had traveled more than 6,000 kilometers. Chinese state reporting places its total lifespan above 15 days, more than 3 times that of a typical typhoon. It survived a journey that normally destroys storms, and it arrived intact enough to require the highest warning level China has. The response tells you how seriously this was taken, and it started 4 days out. On the 5th of August, more than 1,000 fishing boats sheltered at Roshan Fishing Port in Wenling, Zhejiang. On the 6th, at 2 in the afternoon, Zhejiang moved its maritime typhoon emergency response to Level 4, and Fujian activated a Level 4 response of its own. China's National Flood Control and Drought Relief Headquarters and the Ministry of Emergency Management activated a joint Level 4 emergency response covering both provinces. An hour later, 21 water passenger transport routes in Zhoushan were suspended. By 5 in the afternoon, Dolphin was still 1,130 kilometers off the Zhejiang coast. By 6, Ningbo had shut down every coastal attraction and all high-risk marine tourism in the city, and the Guangdong Maritime Safety Administration had imposed traffic controls on vessels moving north through the southern entrance of the Taiwan Straits. An orange alert for waves stayed in force along Zhejiang's coastal waters. Then yesterday morning came the red alert, with the National Meteorological Center forecasting what it called extraordinary torrential rain across parts of central and eastern Zhejiang. The evacuation numbers that followed are the ones worth sitting with. More than 1 million people were moved nationally. In Wenzhou alone, more than 900,000 residents were relocated. In Fujian, nearly 99,000 people were pulled out of designated risk areas on Saturday evening before the storm was anywhere near the coast. More than 1,000 flights were canceled, with Shanghai scrapping the overwhelming majority of its scheduled departures, and rail service was suspended across the coastal regions. Whatever else this event demonstrates, it is not a warning failure. The sequence is documented in unusual detail, and it ran days ahead of the storm. That matters because the claim that people were left unwarned is already circulating, and the timeline does not support it. The wind was never going to be the main threat here, and it still isn't. Rainfall forecasts called for 250 to 500 millimeters across parts of central and eastern Zhejiang. Torrential rain is falling through today across Zhejiang, Shanghai, northern Fujian, northeastern Jiangxi, central and southern Anhui, and much of Jiangsu, and the storm is not finished. The extended outlook carries heavy to torrential rain across central and eastern China through Wednesday, and then a second act, further downpours pushing into North China, Inner Mongolia, and southern northeast China from Wednesday through Friday, as what is left of Dolphin's circulation interacts with cold air moving down from the north. The forecast track has the remnant core moving west, and then slowing over central and southwestern China, weakening gradually as it goes. It is worth translating those rainfall numbers because they get quoted constantly and rarely land. 500 millimeters is half a meter of water, roughly 20 inches, falling in a window measured in days across terrain that is already saturated from a wet summer. For comparison, a great many cities in the world do not receive that much rain in an entire year. When it arrives that fast, the ground stops absorbing it almost immediately, and everything after that point becomes runoff, heading downhill toward whatever is at the bottom. That slowing is the dangerous part. A weakening tropical system that stalls over terrain does not stop being a flood threat. It becomes a more concentrated one, because the same moisture gets wrung out over a smaller area for longer. The wind damage assessment from the coast will be finished within days. The inland flood picture is going to take most of this week to resolve, and it is the part of this story most likely to produce the casualty figures. Now here is where the story stops being about one storm. On the same afternoon, Dolphin was coming ashore in ZheJIANG, Tropical Storm Pelu formed in the western North Pacific, becoming the 16th named storm of the 2026 season. Its formation created a situation in which 3 named typhoons were simultaneously active in the same basin: Dolphin at the coast of China, Chanhom out east of Japan, and Pelu, newly born near the Marianas. Chanhom, designated Typhoon number 15 by the Japan Meteorological Agency, set roughly 1,339 kilometers east-southeast of Misawa, Japan, tracking west at 26 kilometers per hour with a minimum central pressure of 991 hectopascals. It is forecast to peak near 60 miles per hour, sustained late tonight, then make landfall tomorrow evening, roughly 245 miles south of Misawa and 110 miles north of Yokota Air Base, somewhere between 7 and 11 at night, before crossing into the Sea of Japan as a tropical depression. It is a large but weak system. The threat there is rain and disruption, not wind damage. Pelu is the stranger one. At 2 in the afternoon yesterday, it was about 740 kilometers north-northwest of Saipan with winds up to 65 kilometers per hour. By 8 in the evening, Philippine Civil Defense Monitoring placed it roughly 2,200 kilometers east of extreme northern Luzon, with gusts to 85 kilometers per hour, moving east-southeastward at 25 kilometers per hour. It is forecast to keep moving east at 25 to 30 kilometers per hour while gradually strengthening. That direction should get your attention. Northwest Pacific tropical cyclones overwhelmingly track west or northwest, pushed along by the subtropical ridge. A system that forms near the Marianas and then strengthens while heading east is a signature of a steering environment that is not behaving normally. 3 at once is not without precedent, and the precedent is worth having in front of you. 3 simultaneous typhoons occurred in the western Pacific on the 8th of July, 2015, the earliest calendar occurrence on record, which itself broke a mark set on the 10th of July, 1972. Before that, you have to go back to the 24th of October, 1994. 4 at once has happened as well, in mid-March of 2015, and again in November of 2024, when Yinqing, Toraji, Usagi, and Manyi coexisted in the basin, the first November on record, going back to 1951, with that many at the same time. So multiplicity by itself is not the anomaly. What is notable is the company it is keeping this week. And there was a 4th. Invest 98W was identified near the Mariana Islands on the 7th of August at 19.4 degrees north, 146 degrees east, with maximum winds of 20 knots and a central pressure of 1,009 millibars. The Joint Typhoon Warning Center placed it under a tropical cyclone formation alert, meaning development into a tropical cyclone was considered likely within 24 hours. There was a 5th system, too. It just isn't there anymore. Typhoon Kujira formed on the 5th of August as the 14th named storm of the season. It made landfall at Magsingal, in Ilocos Sur in the Philippines, at 2 in the morning on the 6th, with maximum sustained winds of 75 kilometers per hour. It crossed northern Luzon, dumped 100 to 200 millimeters of rain across La Union, Pangasinan, Benguet, and Zambales, and emerged over the Philippine Sea that afternoon, weakening to a tropical depression and then to a low-pressure area. Its remnants were briefly flagged for possible regeneration. Then Dolphin absorbed it. Kujira did not simply dissipate the way a weakening storm normally does. It was drawn into Dolphin's circulation and consumed. When 2 tropical cyclones form close enough to each other, the larger and stronger system can entrain the weaker one's moisture, its vorticity, and eventually its entire circulation. The smaller storm stops existing as a separate entity and becomes fuel. That is not exotic physics, but it is a direct function of crowding. The more storms occupying a basin at the same time, the more likely these interactions become, which brings the 2 halves of yesterday together. The same basin conditions that let a typhoon form 6,000 kilometers from China and survive the crossing are the conditions filling that basin with storms in the first place. Dolphin did not just beat the odds, it ate a competitor on the way. The mechanism behind all of this is not mysterious, and it is not new science. Peer-reviewed work published in the Journal of Climate and elsewhere establishes that Eastern Pacific El Niño events produce a pronounced eastward shift in where tropical cyclones form over the western North Pacific. The reason is straightforward. El Niño warms sea surface temperatures across the central and eastern equatorial Pacific. Warmer water shifts the region of deep convection and low-level wind convergence eastward with it. And Genesis follows convergence. Move the warm water, and you move the nursery. The consequence of that shift is the part that matters for a coastline. Research on El Nino years finds that the eastward genesis shift causes tropical cyclones to spend longer stretches over open ocean, and therefore to attain greater intensities, producing longer tracked storms. A cyclone born over the tropical central Pacific has a longer distance to cover before it hits anything, and every extra hour over warm water is an hour it can spend getting stronger. Dolphin is a textbook expression of that. Born at the far eastern edge of the genesis zone, handed more than 6,000 kilometers of warm ocean to work with, and Category 5 by day 3. Sea surface temperature is only half the picture, though, and the other half is what makes a storm like this durable. A tropical cyclone cools the ocean underneath itself. The winds churn the water column and mix colder water up from depth, so the storm progressively removes its own fuel source as it sits over one spot. That upwelling is the natural break on tropical cyclone intensity. It is the reason most storms cannot simply keep intensifying indefinitely. Right now, that break is failing across a large part of the Pacific. A massive downwelling Kelvin wave has propagated east across the equatorial Pacific, carrying subsurface temperature anomalies of up to positive 8 degrees Celsius between roughly 50 and 250 meters depth. When the warm layer runs hundreds of meters down instead of tens, stirring the water column does not bring up anything cold enough to matter. The storm keeps drawing heat from what is effectively a bottomless reservoir. That is the physical difference between a storm that peaks and fades and a storm that peaks, weakens, re-intensifies, absorbs a rival, and arrives at a coastline 13 days later still strong enough to trigger a red alert. There is an honest counterweight here, and it deserves stating. Ma Jun, director of the Institute of Public and Environmental Affairs, told the Global Times yesterday that early August is the peak period for typhoon activity, typically producing the most storm formations of the year, and that multiple simultaneous typhoons, including severe ones, during this window is normal. By this point in the season, the ocean has been absorbing and accumulating energy for more than 6 months, and the atmospheric circulation is favorable for formation. He is right, and the distinction is important. The seasonal argument explains the number of storms. It does not explain the location of Dolphin's genesis, and it does not explain the record. Multiple typhoons in early August are ordinary. A typhoon forming at the dateline and reaching mainland China is, by China's own assessment, unprecedented. Those are two different claims, and they should not be blended together. There is one historical parallel worth knowing about, and it does not offer much comfort. The 1997 Super El Nino produced 11 super typhoons in the Northwest Pacific, 10 of which reached Category 5, the highest count of Category 5 storms in a single season on record. That same season produced Typhoon Paka, which formed in the Central Pacific in late November as one of a pair of cyclones generated by an equatorial westerly wind burst southwest of Hawaii, and crossed the international dateline on the 7th of December to enter the northwestern Pacific as a typhoon. Paka is the closest thing the record has to Dolphin's behavior, and even Paka only crossed the line from the east. It did not form beside it and then run the entire width of the basin to mainland China. That distinction is also the answer to the most reasonable skeptical objection to all of this. The argument that a first on record simply reflects better satellites. That objection deserves a real answer, and here it is. Records beginning in 1951, or with the satellite era, genuinely do capture events that earlier decades would have missed. A typhoon forming at the dateline in 1930 might have gone entirely unobserved. First on record means first in the reliably observed period, and that qualifier is honest. But the satellite record now covers more than 5 decades of continuous global coverage, including the Super El Nino events of 1982 and 83, 1997 and 98, and 2015 and 16. Those are exactly the periods most likely to have produced a comparable storm, and they were fully observed. The record is short. It is not blind in the places that matter. 3 things are worth watching over the next several days, and 1 over the next several months. In the immediate term, the inland flood picture across central and eastern China is the live hazard. Dolphin's remnants are slowing over the interior. The rain continues through Wednesday, and a second surge is expected to push into North China, Inner Mongolia, and southern northeast China from Wednesday through Friday as the remnant circulation meets cold air. Casualty and damage figures from the coast will firm up quickly. The inland numbers will not. Tomorrow evening, Chanhom crosses northeastern Honshu. It is a weak system, and the expectation is rainfall and disruption rather than structural damage, but it will be moving over terrain that has already taken a full typhoon passage this month. And Pelu keeps strengthening while tracking east, which is the anomaly to keep an eye on, because it is the clearest live indicator that the steering environment in that basin is not behaving the way the climatology says it should. The longer question is the one that actually matters. NOAA's Climate Prediction Center upgraded its ENSO alert status to an El Nino advisory on the 11th of June. The probability that El Nino persists through Northern Hemisphere winter is greater than 96%. The probability of a very strong event, the tier forecasters informally call a super El Nino, peaking between November of this year and January of next, is approximately 63%. Put those two things side by side. The eastward shift in where typhoons are born is an El Nino signature. It is documented, mechanistically explained, and it has a specific quantitative fingerprint, the migration of the genesis zone from 160 degrees east out to 170. Dolphin formed past even that. And the El Nino responsible for the shift has not peaked yet. That does not mean the next storm will be worse. Individual storms are not predictable that far out, and nobody should claim otherwise. What it means is narrower and more useful. The ocean state that made a dateline typhoon possible is still strengthening. The basin is already producing storms faster than the long-term average, 16 named systems by the 9th of August, against a seasonal forecast running roughly 40% above normal, and the peak of the season is still ahead. Dolphin was called an exceptionally rare system by the people who forecast it. The open question is whether rare means it happened once or whether it means it happened first.